Now it's time to investigate the nuances of how sense cubelets communicate. Just a quick reminder, my name is Emily Eisenberg and I am the educational designer here at Modular Robotics. If you have any questions at all during this workshop or any other Cubelets online workshop, feel free to email me at edu@modrobotics.com or tweet at modrobotics using the hashtag #CubeletsChat. First, let's assemble our robot. Start with a right angle using a battery, flashlight, and brightness cublet. Then add a distance sensor to the opposite side of the flashlight. Now add an act cublet of your choice to each end of your robot. This makes a long line of cubelets. Act, sense, act, sense, act. And what do we already know about this construction? Well, first we know the distance cublet doesn't have anything floating above it. I'm not waving my hand on top, it's not facing my water bottle, the ceiling isn't crashing down around us, so I know this cublet will likely have a value of 0. It just doesn't see anything, and it is looking. I also know the brightness cublet is in a really, really bright room right now, so it's collecting lots of light and turning it into the highest value it possibly can, which for now we're going to say is a 10. I know that when these values, the 0 and the 10, get passed back and forth between all these cubelets, the act cubelets are all putting out some sort of action. But the question is how much? What data values are these act cubelets reporting? Are they all the same? Are they all different? Why or why not? Take a moment to pause the video and make a prediction of what you think the data values will be for each of the act cubelets in your system. Now it's time to get out your tool. Remember, this will either be your bar graph or your Bluetooth cublet along with your Cubelets app on a separate device. If you're using your bar graph cublet, we're going to start with you. I'd like you to attach it one by one to each of the cubelets in your robot. Notice how I start with the sense cubelets. This is my way of making sure that I've set up the experiment the way I wanted to, making sure my distance cublet isn't seeing anything and my brightness cublet is seeing a lot. As you go, take notes on a piece of paper or a sticky note so you remember how high the bar graph was when you attached it to each cublet. If you've chosen your Bluetooth cublet, start by attaching your Bluetooth cublet to your actual robot construction. Make sure the battery is on, pair it with your separate device, then open the Cubelets app and pair it with your cublet. Then select all 5 of the Act and Sense cubelets on your screen, one after the other after the other. It'll look something like the screen in the top right-hand corner of this page, although not exactly. Make sure the bottom row shows all of your cubelets in read mode, not control mode. We want all of them to just be collecting information about what the cubelets are doing in their natural environment. We don't want to be remote controlling them right now, though that's something you can definitely play with after the video. The other thing I want you to notice is at the top. We have a percentage. The percentages are really helpful right now, so go ahead and keep them the same. But if you're curious to see what other options are available, feel free to tap on a percentage and it'll change to different numbers. Each of the numbers in these lists are kind of like measuring with different units. The one right after the percentages, for instance, is measuring in binary, so it'll measure anywhere from 0 to 255, and then it'll restart its counting at 0. For right now, go ahead and tap all the way until you get back to the percentages, and that's what we're going to use for this investigation. It's really important that you screenshot your picture. When you double check that your distance is at 0 and your brightness is at 10, that's when you should screenshot. We'll use this screenshot in a minute to analyze our data. You will have noticed that all these act cubelets were not the same. So what's happening? Here's an image of the screenshot I took when I ran this investigation. When I tapped on the percentage bars and switched into binary, these are the numbers I got. Reading across the screen from left to right, the first act cublet on the left is measuring 49%, which is nearly 50% or 5 out of 10 on the bar graph. The next sense cublet is measuring 0, which will be 0 on that bar graph. The sense cublet in the middle reports 99%, which is the same as 10 out of 10 on the bar graph. And the last 2 act cubelets are 0 and 10, respectively. It is really important to keep this data with us, so I'm going to move this image to the top right-hand corner of the screen so we can remember. Remember that this is the robot we built. I, in my experiment, used a bar graph cubelet and a rotate cubelet, but you probably chose something different, and that's okay. Keep them there, it's totally fine. You'll notice I moved the image to the top right-hand corner of the screen like I promised. The first thing we want to do is double check that we know which cubelet is which in our image, so I'm going to start with my sense cubelets because I already know in my head which one is which. I know that the first sense cubelet, not only does it have two little eyes on the screen, which gives me a good hint, but it's also at 0. 0 means that this must be the distance cubelet, because I know the distance cubelet isn't looking at anything. I also know the second sense cubelet, this middle one, not only does it have that big bubble eye like a brightness cubelet, which gives me my clue, but it is also nearly a full 100%, which we are calling 10 out of 10. I know it's a really bright room that I'm sitting in, so I know this cubelet has a value of 10. But which of my act cubelets is which? I'm going to start with the act cubelet on the far left side of the screenshot. This one's measuring a 5. I can tell in the picture that it's a picture of a flashlight because it has that really bright light shining out of one side. So I know this means in my robot, this middle flashlight cubelet is measuring a 5. The 0 cubelet in this very clearly has a bar graph image on it, so I can mark that one over at the very end of my robot, labeling it as having a 0. And the very last one, for me, it's a rotate. You can see the image of the rotate on the top of my cubelet in this picture. That means that my rotate has a value of 10. Great. We've filled in the numbers, but we haven't explained why they are what they are. So let's take a look at our robot a little more carefully. You leave your robot attached, but in my picture, I'm going to spread them apart so we can look at what's happening in between each cubelet. So let's remember what we know. We know that the brightness cubelet is receiving a lot of light from the outside, and we know the distance cubelet is receiving very little because there are no objects around it. I'm not waving my hand above it, so we know that they're a 10 and a 0, respectively. We also know that cubelets then communicate their data value to all of their neighbors. So the brightness cubelet is speaking to the left and to the right, and the distance cubelet is speaking to the left and to the right. And now we've got a lot of arrows, and we still need to figure out what these values are really going to be. So let's start by looking at the ends first. When we look at just the end of the cubelets, we see that the rotate cubelet from my last picture had a value of 10, which makes a lot of sense. It's receiving only one data value from the brightness cubelet that has a value of 10 also. Hi, my name is Brightness, my value is 10. Great, as a rotate, I'm spinning as fast as I can. On the opposite side of the spectrum, the distance cubelet has a value of 0, and it's passing that information to my bar graph. My bar graph almost looks like it's not working because it has a value of 0 too. And that makes sense because the bar graph cubelet is only receiving one data value, and that's from the distance sensor close to it. What we know from this part of the experiment is that sense cubelets do not pass any data through them from other sense cubelets. They're very selfish that way. The only thing sense cubelets do is look around their environment and collect whatever number is out there. It doesn't matter how many times you yell in the ear of a brightness cubelet, coming from any other cubelet in your robot construction. It just won't listen. All it does, all day long, is look around for light, change that into a number, and pass it on. That's it. So we know sense cubelets do not communicate through each other. That means if you put them next to each other in a robot construction, they could actually act like a blocker. And what happens when we're looking at the cubelets in the middle? This flashlight cubelet in the middle of my robot construction is receiving a 0 from the distance sensor and a 10 from the brightness sensor. And we know from our experiment earlier that it's measuring roughly a 5. Well, this can be explained pretty simply. Cubelets are built so that anytime they are receiving more than one data value, they take something called the weighted average. This means they take the average of the values they're getting. I've got a 0 on one side, a 10 on the other. My happy medium, my middle point, is going to be a 5. It is important to know, though, that this average is weighted. To show you what this means, let's rearrange our robot, putting all our act cubelets in the middle, then the brightness on one end. Make sure the battery is on so you can see this. Then the distance on the other end. Whoa! Did you see that change? Take off the distance cublet, and then put it back on again. This is an example of weighted average. Now it's time to measure it with your tool, either your bar graph or your Bluetooth. When I ran this experiment, I used the bar graph to measure these values. See how all of the ACT cubelets are not reporting the same value? This is a great example of how weighted average works. Sure, all the ACT cubelets are listening to both senses, but they give more weight to whichever one is closer. This creates almost a watercolor effect in our robots. So, what have we learned in this video? We've reviewed that sense cubelets listen to nobody but themselves. And we know that ACT cubelets take the weighted average when they receive multiple different data values from various sense cubelets. Do you still have any questions? Remember, you can tweet at modrobotics with the hashtag #CubeletsChat, or you can email me at edu@modrobotics.com. Happy building!